Hey everyone, it's Devan. So this video is going to all about the object detection. Okay, so this is going to be help you out started with machine learning. Okay, so we basically using here OpenCV for our object detection. Okay, so let's get started. So before you have to get your hand dirty in machine learning, what you have to do, just go and search about how to install OpenCV in your machines, okay, in your respective operating systems. I have installed it using the sudo apt install OpenCV. So I go directly to my terminal, okay, and from here I'm actually using Sublime text editor, but you could use any text editor, or even if you want to use Jupyter notebooks, you can go with that. Okay, so I'm using OpenCV and Sublime text editor, and my default Python version right now is 3.6. Okay, so I'm using Python 3.6, and if you're using Python 2.7 or something, then just check out the differences between both. Okay, so you don't have to get the errors, so you don't get any errors. Okay, so let me just first write the command. So object detection py. Okay, so I've created my file here, and for starting it, first let's import cv2. Okay, so it's our OpenCV that we are importing here, and we need to also import random. Okay, so I'm going to import random, and we need import maths. Okay, because we are going to use a sqrt function of the maths library. Then we need to, yeah, we need to import also numpy, and to install numpy, just write the command pip install numpy. Okay, in any of the browser it will install numpy. Okay, so import numpy as np, oops, np. Okay, then from collections we are going to import dq. It's a data structure, we are using it here for storing the detection path of the object. Okay, so we're going to import it. So from collection, import dq. Also we're going to use matplotlib. Okay, so from, or maybe we don't, okay, we will check it out when we use matplotlib. So to capture our video from camera, we actually using here camera to detect or to capture the surroundings where the object is lying currently. So for that, let's create a variable cap, which is a reference to the object. So cv2 dot video capture. Okay, okay, so and put a zero here. Why zero here, let me tell you. So this is my GitHub repository, and I have actually explained each and everything here. So if you want to refer this, you just go up there and read this readme file. Okay, so video capture, to capture the video, we actually have to create the video capture object as we have created right here. Okay, and it's currently the reference variable name is cap. Okay, so its argument can be either the device index. Okay, so by default, if you're using a laptop, so it will be the 0 of your default webcam in laptop. If you're using external webcam, that index will be changed, or you have to write the name of that, okay, of that video file. So if you just pass the index or just a number to specify which camera, normally one camera will be connected. Okay, so just simply pass 0 or -1. Okay, so that's how it actually gets capture our object. We are going to capture it using through our webcam. Okay, so after creating the object of this webcam, let's create our data structure where we are going to store everything. So let me create dq here. Okay, so I'm going to create a dq, to store all the points that are traced, that are actually traced by this OpenCV. Okay, so to do that, I'm going to create a variable named as center points. Let's take it as center points. Okay, so center points. Okay, and here I'm going to create using the constructor. Okay, so this is a DQ's default constructor. To create a DQ, to initialize a DQ, it's going to be an empty DQ. It is basically same as the list constructor that we have seen in Python. Okay, so now DQ is created, and we also going to create a DQ for the redo command. Okay, so we are going to also put a redo option here. So let's create another DQ for redo. Okay, so DQ. Okay, now we're going to define the range of colors that to be detect. Okay, we want our program to detect a specific object, a specific colored object. To do that, we have to define the range to from up to that this color benchmark you have to detect till this benchmark of the color. Okay, so to do that, we're going to define lower green. I'm actually going to use green, and if you want to use any other color, okay, so just I have found out a website where you could see this, or if you go, you can find out the HSV color range. Okay, so this is basically the website. Its name is workwithcolor.com. Okay, so I'm actually find out the green colors range, the specific green color that I want to detect by this algorithm. Okay, so it's all up to you. Just go and google about the color range. Okay, and we will see what HSV and what other things are. Okay, so as we have created our DQ to capture the path. Okay, and this range we're going to use numpy here to create the matrix here. So lower green and upper green. Okay, so it will define the benchmark up to after above crossing this value of the color, we have to detect the object till what color. Okay, so these are the those values. Okay, so lower green equals um, np dot array. Okay, and let's create the numpy array. So we're going to 50, let's say 150. Okay, so it will detect the green color and also the upper green. Okay, so the upper value till it has to detect the green color. So upper green equals np dot array, then maybe take it as 89, let's say 90 here, and 255, that's the maximum value. Okay, and 255. Okay, so we have defined our range of the colors that we have to detect. Okay, now we want that the capture that we have, the thing, the video actually that we are capturing will open the window where we can see ourselves or see the object in the video, whether the object is being able to detect by the camera or not. We have to open that window. Okay, so we don't want it to close unnecessarily or in between of the detection. Okay, so for doing that, we're going to create while loop, which will be initialized as true for an infinite loop. This is basically going to be an infinite loop. Okay, so now we're going to read the frames. Okay, the camera that is going to capture the video, we're not going to read the frames from it. Okay, so let's say red and frame equals cap. Okay, so cap is our object here. Okay, the object of the video, it's a video object, and from cap dot read. Okay, so we are going to read the frame. Then what we have to do, actually it records the video in the same manner that you're facing. For example, if you move right, the videos goes to the left. Okay, is in front of the right. It's not the actually the true mirror image. So we want to see the mirror image because we have this habit of seeing ourselves in mirrors. So we're going to flip the frames. Okay, so frame equal let's just flip this by the OpenCV's function flip. Okay, so just flip this and it will flip the frame. Okay, and also initialize pass the frame. Okay, so frame comma 1. Now the part, if applying here, we will do the task related to the object. Okay, so if red, um okay, so let's put here, so if red, if red, okay, basically if I say red is the actually it is the written value. Okay, so whether it has successfully read the frame from the input video, okay, or not. If it is true, if it has successfully read the frame, what we have to do is just to perform the task on that frame. Okay, the frame that has captured the object. If the frame is if the frame is got read by our function by the camera. Okay, if the camera is working and if it has the object, what we have to do. Okay, so we're going to create another frame. Let's name this to frame 2. Okay, and we're basically going to apply here the Gaussian filter, and I will tell you what Gaussian blur filter is. Okay, so let's first write this function. Okay, so Gaussian blur. Okay, so blur, and here we're going to pass the frame. Okay, frame and the values. Okay, 5 and let's write this as 0. Okay, so what is Gaussian blur? So let's see this. So we have flipped our video. Okay, so it's these are the parameters. We have our source, okay, in the function, then destination and the flip code. We got our source and the flip code here. Okay, we have flipped it, and now the Gaussian blur. So actually basically what Gaussian blur here does, it just removes the noises. Okay, we got a lot of noises in our image while reading from the sensors. Here our sensor is the video camera, and it also got some, what I mean to say is the noises. Okay, so this is the original image right here, and after applying the Gaussian blur, it just smooths out that image. Okay, so if you want to read about this whole thing, I have written down this into the readme file. Okay, so just go and read. So our next function will be the HSV. Okay, so we will actually going to use CVT color function of OpenCV, and HSV stands for hue, saturation and value. Okay, so in color space, actually it is a model to represent the color space. Okay, so similar, which is to RGB that we actually use in mostly in web development, but HSVs are much more, has a lot of advantages. Okay, and what RGB values could not do, it has actually it has a large number of color sets that we can use. Okay, color shades if I say. Okay, so these are the color RGB value color space, and that is actually the color space of HSV. Okay, so you can see the difference. There is saturation, there is not such a thing, but there is just RGBs. You can have a very limited amount of colors, but in with using HSV you have quite a lot of range with working with colors. Okay, so let's write related to HSV here. So let me create a variable called HSV. Okay, and here we're going to use the cvt dot color. Okay, so just convert the color. Let's pass it here frame 2. Okay, and cv2 dot color brg to HSV. Okay, so I'm going to tell you about what this is. Okay, so cv2 dot p color, I mean, and brg to HSV. So BRG is to gray, and BGR actually BGR to gray, and BGR to HSV. So for color conversion, we use the function here, the this function, okay, and flag determines what type of conversion. Okay, so BGR to HSV, we use the flag CV2 dot color BGR to HSV that we have seen right here. Okay, actually, BGR is basically the RGB that you see today, that you use today. Okay, so RGB value, but back then, when the OpenCV was developing, actually at that time, cameras actually uses BGR at that time. Okay, so we have to use BGR and we have to convert that to HSV. Okay, so that's U saturation value. Okay, so that's the reason why we have BGR here. Okay, now I'm going to also create a mask. Okay, so what mask is, let's see. So mask basically is used to find the that this objects array, actually this objects is going to be converted into the set of arrays. Okay, according to its color, and that actually belongs to that range in between the lower green and the upper green, that the limit that we have set it. Okay, so that's where that's why we use mask here, to check out whether the object lies in between those matrices or not. So let's create mask equals, and cv2 dot in range. Okay, so cv2 dot um in range. Okay, and hsv comma lower green. Okay, so we are just passing out those values here, and upper green. Okay, now we had created our mask here. Okay, and now we're going to apply morphological transformation. Okay, so what morphological transformation is, so let me also add one function here, which is bitwise and. Okay, so I'm also going to produce another output, which basically is the combination or the bitwise and of our two video inputs. That's the one which is the original video output. Okay, the input that is going on, and the another hsv converted values. Okay, that's the black and white. Okay, so just 0 and 1 video values. Okay, so I'm just going to combine both of these so we can only see the object, okay, from the entire video. So let's add this function here. Let me just copy and paste it here. Okay, so that's actually going to bitwise and actually, if you see what I actually want to do with, if we have input like this, just think about this as input for now, and we want that green and yellow colors will be detected. Okay, so we got our green color here, we get our yellow color here, and we get our these both colors. Okay, so this is actually the output that I wanted. It's actually just going to show me the only object. Okay, so that's I really want to do with my object that I want to detect in the video. Okay, so let me just paste it here. Okay, now let me just apply morphological transformation. And what morphological transformation is, okay, and actually I'm going to create an ellipse. Okay, so we need elliptical and circular shapes. Okay, so if you could see, a rectangular kernel is created. We actually going to use get structuring element function here, and the morph rectangle, we're going to create it as a 5 cross 5 matrix. Okay, and as you can see, it is filled with all the ones. Okay, so that's a rectangle here. Then if we are going to create an elliptical kernel, that's what we are going to do right now. Here we created a 5 cross 5 matrix. Okay, so as you can see, it's a elliptical shape. Okay, if we see that these ones are forming an elliptical shape. Okay, then morph cross, as you can see, this is creating a cross here. Okay, so that's what we are going to do right now. Okay, let me just copy and paste this from here, just saving a little bit time. Okay, so we're going to create a 10 cross strand matrix. Okay, and creating a ellipse around that object. Okay, so we're going to see how, what am I going to do right now. Okay, and what we are doing. Okay, we will clear this thing in few lines more, okay, after few lines. So now we're going to apply a morphological X, and what that is, let me tell you first. So there is something called morphological transformation, okay. They are some simple operations based on the image. Actually the image right now is a frame, okay, so we are working on the frame, and it basically performs on the binary image, okay, and it needs actually two inputs. One is our original image, and second is the structuring element, okay, of which decides the nature of operation. So two basic morphological operations are erosion and dilation, okay, and what those are we're going to see, okay. So for example, this is our going to be the input image, okay, so this is our input image. Let me just zoom in. Okay, so that's how our input image looks right now, okay. And so erosion, the basic idea of erosion is just like soil erosion only, okay, so it erodes away the boundaries of foreground object, okay. Always try to keep foreground in white, okay. So that's what erosion is, okay. So it just, as you can see, our original image was that, and it just eroded. Then dilation is just the opposite of erosion. Here, a pixel element is one if at least one pixel under the kernel is one. So it basically what it does, it increases the white region in the image. Okay, so that's its dilation. Then we got something called opening that we are going to do in our image. Okay, so this is somewhat like erosion, but it removes noises, okay. So whatever the noises that it captures around the object, it will remove by this opening function, okay. Then the closing, which is the opposite. So let me see. Okay, that's the problem. I will change the image, okay. So actually closing, what it does, if there is noise in the white region, it removes that, okay, not this image, but think about the black dots in between this white strips here, okay. So it will be removed by this close function, okay. The closing function will do that. And then morphological gradient, it's the difference between the dilation and erosion image, okay. So the part that is dilated and the part which is left after the erosion, so that's what the morphological gradient is. So we're going to use actually the opening, okay, and we going to actually remove the noises around the object, around our object. So cv2 dot get structural element, okay, get structuring element. One second. I think, oh, I've used this. I actually I'm actually doing the morphological operation. Okay, so morphology X. Okay, so morphology X, and let's add the mask. Okay, and cv2 dot morph open. Okay, cv, and the kernel that we created above. Okay, now we have applied the morphological open operation, okay. We actually remove the noises around the object. Now let's time to get the contours, okay. Let's get our contours. So len, okay, and one thing, I think I haven't get the contours back, okay. So okay, so let me just write this right now, okay. Contours, okay, if the len is greater than 0. Now I'm also getting the contours, and what contours is actually, contours is actually the uh, region where we can get the maximum value of our detected object, okay. If we got detected our object and the contour value is the highest, actually the color which is way much perfect for which is actually gets the gets us the best matrix pixel. Okay, so if we got a pixel matrix and which is the best, it selects that, and that's our contour. Okay, actually that's the point which will be treated as the center of the object. Okay, so contour is that it will be actually treated as the center of the object, the object that is got detected by this algorithm, and that will be used to trace the path over the entire session. Okay, whenever we move our object, it will be treated as images since we are working on frames, and it will be taken as to check out the movement, the movement part, and we will see what movement is, okay, in images. And that's how we actually going to create, that's why we are going to create the contours. Okay, so um, image. Okay, we also need contours. Okay, and then hierarchy. Then cv2 dot find contours is a function that we have to use here. So cv2 dot find contours function, then opening. Okay, so we created our opening and we are going to now using opening here. So opening dot copy, it's a copy function, and cv2 dot tree. And actually rated tree, what it does, it actually creates it actually assigns some values to different objects. Actually find contours function, what it does, it actually finds not only the contour, the hierarchy here is actually assigning the hierarchy of the object. Okay, sometimes we got do our object inside another object, like something called nesting here. So a tree actually assigns who is the grandpa, who is the father, who is the child, who is the grandchild. Okay, the it assigns the IDs to differentiate the final object. Actually it creates for each object, each detected object, that's the grandfather, parent and child, it creates contour to it and it finalizes which is the perfect one. Okay, so that's how it actually works. And then we got our cv2 dot chain approx simple. Okay, so chain approx and simple. Oops, simple. Okay, so let me just make it a little bit down here. Okay, so that will be helpful for you. Now coming to the part to if. Okay, so in if we actually got our contour, if the contour value is 0 greater than 0 is greater than 0, actually if we got detected our at least one contour, so we have to now get the largest contour, which one is the largest. Actually we got a lot of objects, we maybe got a lot of objects inside one object, so we got a list of contours, we actually created a tree, and now we have to find the best fit, which is the best contour, okay, in all of these. So to do that, what we have to do, let me just create another variable, let's name is largest contour. Okay, and apply a max function. Okay, so it will find out which is the biggest. So from our contours, we're going to find out the maximum contour. Okay, so that is contours, and here we're going to find contour, and let's set the key equals cv2 dot contour area, which will be used as to find the maximum contour. Okay, so which has the maximum area, it will be selected. Okay, so cv2 dot contour area. So now we're going to about, now we find out our contour, the biggest contour. Now we have to apply moment. Since we are moving the object here and there, we have to use the moment formula. Okay, so that will be, let's create the moment equal cv2 dot moments. Okay, along the largest contour that we got. Okay, so uh, largest underscore contour. Is the spell, I spell the right? Okay, yeah. So now calculating the center point of the largest contour. Now we're going to calculate the center point. Okay, so center underscore point. Okay, so we're about to calculate the center point. Let me, okay, nah, I'm not going to use that much, or maybe I should. I'll let it be center point. Okay, so we're going to create int, then moment, and in a moment I will tell you what I am doing right now. Okay, so in a moment I will tell you what it is. Okay, so m10, okay, m10, and divided by moment. Is the spells? Yeah, I think spells are right. We will check it after run this script. Okay, so moment 2, then I put a comma here, and again let me write int. Okay, then moment up around actually around the y. Okay, so that would be m01. Okay, so m01, and let's divide this by again moment m00. Okay, so what I had done here, so let's see. So moments actually in computer vision, we now actually going to move our object. Okay, so this function actually what it does, it's a moments formula, and it has as ij, so x to the power I and y to the power j, and its inertia. Okay, so actually we converted our image into a zeros and one. Actually if we put I equals 0 and j equals 0, what happens here is that it becomes the total area. Okay, it will be calculated, because since they becomes 1, and we actually going to calculate the total area, and that's what we are doing here. M00 actually means the total area of the object. Okay, of that contour region. Okay, so since it's a binary image 0 and 1, we have converted it to hsv. Actually we use the bgr to hsv function there. Okay, and it's since so actually we got moments, and we got even second order moments. Okay, or the first order moments, or even the zeroth order moments. We got this type of moments. So zeroth order moments is the, if you put I and j equals 0. Okay, so that will be our zeroth order moments. Okay, so now because the area of the picture that's non-zero. Okay, that's just the sums, the counting up to the non-zero pixels. Okay, so the problem with regular movements is, of course, is that they are sensitive to what the x and y position actually is. Okay, so you need to want the moments of shape to be independent. Okay, or where the shape is, we have to find where the shape is. So there is something called the central moments. Okay, and this is here is the central moment, and actually they subtract off the mean of x. This is mean of x and this is mean of y, and it is otherwise just the same. So that's this mu pq, mu sub pq, and it's x minus x bar uh, to the p, and y minus y bar to the q, and the inertia. So what x bar is? Well, one way of thinking, it is the average of x. So the average x would be just the sum of all the x divided by how many x are in there. Okay, so that's the x average, and x bar is m10, the first moment in x divided by all over the area. Okay, so remember 0 0, we have talked about m00, so m10 is actually the first moment in x. And of course is that they are very sensitive to variety of changes. Movements are sensitive, so if we scale the image up, right, obviously the movement's going to change. So the area will get bigger, the distance get larger. Okay, so that's what about movement is, and that's the same for the movement of the first with y. Okay, so that's why m01 and that's m10. Okay, so that's we have done with the movements. Okay, so coming to our point, we got our movement, we got the center, we got the movement at the center, we got the total movement, we got the largest contour where we have to apply the movement, we got the center point. Now it's time to circling the area. Okay, circling the points. So to do that, we have our cv2 dot, what I say, circle. Okay, so circle here, and let's what we where have we draw this circle. So frame. Okay, and center 2, I mean center. Okay, so center, actually I've used center point. Okay, so center point here, and let's apply it to 10. Okay, that's the radius of the circle here. Okay, this is the radius, this is the object, this is the radius. Then after applying the radius, what color it should look like? So 255 2550. Okay, so 255 comma 255 comma 0. Okay, and let's add it to 1, and then cv2 dot line underscore aa. Okay, so now we got created our circle here, and our center points we're going to, 1 second, let me think. Center points, have I used this name? Yeah, I've used this. Oh, sorry, I couldn't use this right here. uh, but that was center points though. Okay, so I could use center point. Okay, okay, no worry, no worry, no worry, no worry. That's center point here. Okay, now okay, that's fine. Yeah, I know sometimes things like this happen. Now we're going to append this center. Okay, actually we're going to append this center to the list, okay, that we got. Okay, so then cv2 dot, let me append this using the append left function. Now cv2, no, I don't know what I'm doing, let me think. Mm, it will be, actually yeah, it will be the, it will be the dq list. Okay, so center underscore points dot append, and up to where, from left. Okay, so we're going to append it to left, and the center point. Okay, so center underscore point, don't confuse about, that's the points and that's point. Okay, now now we have appended, and if we press the R button, that's the redoing, so we have to clear that buffer, or the dq if I say so, clear function there. Okay, so we clear that. After done this, after doing this, let me also add another thing before, after if ended. So for I, it's the main part of our, which shows the video output, input and everything here. Okay, so for I in range. Okay, so we're going to start from 1 to length center points. Okay, so it will be keep going until the it actually shows the output until we got our center points. Okay, so center underscore points, have I spelled right? I think so, I spelled it right, everything. Okay, that's different. Yeah, I got the Oh, indentation problem, So we're going to draw the line if the distance between those points is less than 70 pixels. Okay, so we're going to use b equals called random module. Okay, so we're going to use random module, then rand int. Okay, and rand int, then let's say use 200 comma 245, and g equals, okay, random dot rand int. Okay, then need to use from here about 100 to 200. Okay, now if the distance formula is here, so math dot sqrt function, okay, for square root. And now we're going to do the difference. So the center points, it's going to be a long line. Okay, so I don't going to do this here. So let me just go to my page. I'm just going to copy out that line. Okay, so that's actually going to be a very big line. So center points to this thing right here. Okay, see, we got the center line. That's the formula for line distance. Okay, and let me also get this thing down here. Okay, so you could see, now you can see what is happening here. So that's the distance formula, and if it is actually distance is between the 70 pixels, then we use that. Okay, so now we're going to show the output. Okay, so now showing the frames, so cv2 dot I am show, that's the function to show the frame. Okay, so I am show, and let's name this frame, the original frame that we have, then frame here, and we have flipped it. Okay, remember we have flipped the frame actually. And then again cv2 I am show function, then let's say image. Okay, and image, and here we will let's so what we have created at the top is res. Okay, so we are going to print res also. So res here. Okay, and now getting the input from the keyboard. So to do that, let's name this as k equals cv2 dot wait key. Okay, so wait key, it wait until the key is pressed, so 1 and bitwise and. Okay, so we're going to do bitwise and here, and 0xff, that's actually the hex value. Okay, after doing this, let's check whether what k is. So if k equals q, what do we have to do? Just quit it. Okay, so we're just going to quit from here. um Actually no, that actually is in the char, and we have to test it. So I'm going to use the odd function here. Okay, so cap dot release, that will actually close the window entirely, the program, it will quits the program. Okay, so release. Okay, then break, so we could actually, oh dear. Now after this we have to check for undo and redo also. So elif, oh actually let me just copy from here. So for undo we use the same thing. I will tell you what they are. Okay. Why they are going outside that much? Oh, actually, I have done some mistake. Oh, okay. So that would be great thing. Okay. So let me select these lines from here and shift tab. Okay. That's my fault actually. This for loop is just for here. I forgot it to put this thing outside the for loop because they do not belong to this for loop. This for loop is all about calculating the points. Okay. And create checking out the distance. Okay, so we got our finalized program from here, and that's what it's. So if k equals q, just release the cap, just release the video capturing object. Okay, and break from here. And if that doesn't happen, just release it. If anything goes wrong, we put this function right there and we destroy all the windows that is being created after this. So let's just save this. Okay, so now it's time to run this script. Okay, so let me run this through my terminal. Okay, and let me just minimize this here. And to run this script, let me just run this through from Python command here. Okay, and it will run. Oh yeah, now it ran successfully. So hi first of all, and let's test it out using the green object. Okay, so I will use a green object right here, and it is detecting right now. Okay, maybe why these noises are here, because due to the reflection. Okay, I will tell you that also. Let me use something from the back. Okay, so it will be not that much reflection there. Actually, this is due to reflection, light reflection. Okay, but yeah, it is detecting the object. As you can see, it created a contour there. Okay, and if I actually put down there, it is not that much stabilized. Actually, it's having a problem with detecting the contour. But yeah, as you can see, it created a circle over the contour. Okay, as you can see, and that's how it is actually detecting the object right now. I don't know why it is not detecting that much, but yeah, it is detecting it. Okay, so that's what object detection in Python. And in the next lecture, I will see you much. I will actually going to explain much more about these object detection and what machine learning is, and we will see much more in machine learning. So as always, thanks for watching. Bye.